Greetings psychology students, teachers et al. This is an update from a clip I made nearly a decade ago where I went into the ingredients of our hypothesis operationalising variables, and since then, as of 2023, VCAR have updated the study design, got rid of operationalising variables and added in controlled variables, hence the rationale for this video. So before we talk about controlled variables, I'd like to recap what we mean by a hypothesis. So it is a testable statement about the predicted relationship between two or more variables. Which begs the question, what's the purpose of the hypothesis? Well, the value of the hypothesis is that by making a statement about the predicted effect of a manipulation of the IV on the DV, then we can make a cause and effect statement that can be validated through repeated testing. Keep in mind, the research hypothesis does not include the controlled variables. It does include an IV, the variable we manipulate, to see how that will affect the DV, the variable we'll measure. We'll make a directional prediction in terms of what we think will happen in terms of the manipulation of the IV and its effect on the DV. And we'll specify the population if that's relevant. So if our study is on VCE students, then we'll start off our hypothesis by saying it is hypothesised that VCE students, blah, blah, blah. So let's look at a scenario where the controlled variable will come into play. So here we've got a proposed study that's going to look at the effects of having caffeine in your system and how that will impact memory. So therefore we'll conduct a within subjects experimental design. So therefore we can eliminate the impact of participant-related variables affecting the results, such as their memory capacity and their tolerance and usage of caffeine. And so we're going to need a control condition. So we're going to test their memory using an identical task, once with caffeine in their system and once without. So therefore, to eliminate the placebo effect, let's use a decaffeinated drink and not tell them until we go through the debriefing process that actually one of those drinks did not in fact contain caffeine. So let's look at our hypothesis here. Have we got the four ingredients? Let's start with our IV. Caffeine versus non-caffeine. IV, tick. Have we got a DV? How many words they actually remember? Have we made a prediction? Yes, we're predicting that they'll remember more words when they have caffeine in their system. And have we specified our population? Up the top here we've got VCE students because that's who we're actually testing. So before we launch in and conduct this experiment, we need to think about the potential for extraneous and possibly confounding variables affecting our DV. So an extraneous variable, any variable other than the IV that may affect the DV, we're manipulating caffeine versus a non-caffeine decaffeinated condition, but there are other factors here that may affect the DV, such as time of day. We might be better in the morning at memorising content than in the early evening, so we need to think about how we control that. Also the type of drink, so for instance, does it make a difference if they're having a sports drink, tea, coffee, etc.? So we need to think about that. And also background noise. So all of these are variables other than the IV that may affect the DV. They're extraneous, potentially confounding. And so this is where the controlled variables come into play. So therefore, we test everyone at the same time of day. We control their caffeine dosage, the timing that they have it, what they're drinking prior to that, and we control noise. We put on maybe some noise cancelling headphones. So therefore now we've actually endeavoured to eliminate these extraneous, potentially confounding variables, which is the whole point of being proactive in terms of thinking about the variables that we need to control so that we can be confident that the only thing that's affected the DV is the manipulation of the IV.